Good afternoon. I have the horrible task to keep you from the after lunch dip, which means if I don't make enough fun here, then you'll probably all fall asleep, especially if you're older like me, right? We like to take small naps. It's good to be back on the stage. I did the opening keynote last year at the first event, and I realized this morning that I actually was the first person to speak at DevOps Brussels, actually. So that's cool, or Fox Days Brussels. This is a different talk than I did last year. This is a talk about how organizations get stuck, and some ideas of trying to get them unstuck. And then you might think, oh, this is another boring talk about Agile. I'll promise you to bash Agile and Scrum, for that matter. But I'll also try to explain why I do this, right? So to start this talk up, because we're going to go into why companies are getting stuck, or organizations are getting stuck anyway, I think I should start a little bit with some talk about quality. Now, quality is an interesting concept, and you might think, oh, boring concept, quality, but hear me out. So it starts with, if you go into the supermarket, in my case, it's the Albert Heijn. I'm from the Netherlands, right? So, and you go and buy some coffee. Now, on the lower whatever they are, there's the slightly cheaper coffee, right? And all the way to the bottom is the cheapest coffee, and then the more it gets into your eyesight, they put the most expensive coffee there, right? The reason is they want to sell that through, right? Now, the thing about quality and coffee is that usually is that the higher the quality of the coffee you buy, the more expensive it is, right? Because, well, they do whatever they do with it. I have no idea what they do with it anyway, but so quality comes with a price. It's the same with if you buy a car, whether that's second-hand or not, doesn't matter. The higher the quality, the more features it has, the more expensive it is usually. All right, so if it has like all sorts of dashboards and nifty things and whatever it might have, an electrical opening for your trunk and whatever, it gets more expensive, right? And if you want to buy a cheap car, then you get a less higher quality car. Now, that's an interesting concept. We're all very much used to it. That means whenever we buy something, we usually get to the point where we have to sort of weigh out the amount of money that we want to pay for something versus the quality that we expect from the product we're buying, right? And since I'm Dutch, that means we're also way to the, what is it, on the left side, right? We want everything to be cheap. Doesn't always work out because we used to buy a lot of stuff that does not have a proper quality. Now, the thing with software is, because of course we're going to talk about software, with software, it is slightly different, actually. It's not the same, because quality in software can mean lots and lots of different things, right? It's not necessarily the higher the quality, the more money you pay for it. That's only what we think it is, and what a lot of managers also think it is, right? Because they think, oh, we spent 2 million on the system, so it must be good. Well, probably not, actually. The funny thing about quality in software, that it is actually, it's highly intangible. It is very hard to grasp what is actually quality. And I know there's people in the industry who actually try to quantify that, like Adam Thornhill, for instance, does that, right? He wrote a book about your code as a crime scheme, and he has an excellent tool to come with it called CodeScene, which is really nice if you want to analyze your repos. But in general, we're not quite sure about quality in software. And the thing is this, right? So whether or not you're going to invest in quality depends basically on what you're doing. And it means you have to strike a balance between being fast and being good. And you're all thinking, right, well, a lot of people, like if you buy, let's say you want to build just a small mobile app to show you the train departure times from Brussels station, right? I looked at the one from the official Belgian Railways yesterday because I was going to Leuven, and I was like, yeah, I could probably build this myself in a day or two, right? You could probably do that if you have the right APIs and the right data. And you can build it, and you can put it out there. You can put it in the stores, and the stores might accept it. Good. All for the better, right? And you don't have to think a lot about quality. But if your software has to run for a very long time, and a very long time meaning maybe even longer than you are old, then you have to reason about quality in a very different way, right? So if you are an old guy like me, I've seen software that runs for 30 years or more. Can you imagine that, software running for 30 years or more? It does, actually. I see the old people in the room nodding. Sorry, no offense meant, but it's 30 years, actually software is still running. It's usually on screens that are black with green characters on it, character-based. Most of you have probably never seen that, but it doesn't matter. So that is a very long time. And if you have to maintain that software for that period of time, you better be aware of quality. Of course, 30 years ago, we didn't have things like unit testing or TDD, or we didn't have CI/CD. We didn't even have version control systems. Even worse, we didn't have the internet. This is hard to imagine these days, right? There was a time, we didn't have AI, by the way, too. We only had I, like, well, whatever. So the question is, if the title is Unstuck, how do organizations get stuck? Well, they get stuck in two things mainly, I think. That's the sort of problems I meet. First of all, technical debt. Do you have technical debt? Yeah, you all have technical debt, right? Do you know why you have technical debt? No, that's a very different subject. I'm going to explain a little bit about technical debt. So, here's the guy who invented the phrase technical debt, Ward Cunningham, also the inventor of the wiki. And he said somewhere in time, shipping first-time code is like going into debt. A little debt speeds development, right? You go faster. Oh yeah, let's cut some do some shortcuts and don't do this and don't write tests and don't do this. So we're faster, and it's all good as long as you pay back the debt. So in the long run, when quality becomes more important, it is important to pay off that technical debt. And a lot of companies do not do that because they stay in this mode of saying, let's cut these corners so we'll be faster. But faster isn't always faster in the long run, because faster in the long run, it does in the short run, but in the long run, it requires quality. And here's the thing. As he says so nicely and eloquently, he says, entire engineering organizations can be brought to a standstill under the debt load of an unfactored implementation, object-oriented or otherwise. Doesn't matter if you do FP or you write COBOL or if you write Java. It's the same for every language. It's the same for every ecosystem. You get stuck. And I've worked for organizations that got so stuck that they couldn't get out of it anymore. And that actually happens. I hope not in your organization, but you might realize that at some point you can get here. So let me give you some of the examples from my own career. Let's put it a career, right? So in 2014, I started working for an insurance company. This is their actual building. And this was a really weird insurance company. I'm not going to talk about the culture at this company because that sucked, but I'm going to talk about their technology. So they had what they call on-premise legacy. They had a mainframe in their basement. Remember, a mainframe, I probably have no idea what a mainframe is. A mainframe is a really, really, really big computer. And it took €1 million per year just to keep the thing running without adding any value to it, right? So this thing sat in the basement, not this actually thing, but the same model actually sat in their basement, and they had to keep it running. It got worse. They also had lots of legacy code. To give you a precise number on this, they had 18 million lines of COBOL. 18 million lines. They also had, by the way, 12 million lines of Java. Right? Now, make a choice. No, they had both, actually. So, and the problem with that, and this is actually from their code base, is that this code is written in a language where we didn't have the space to write long variable names and long function names, so they had to abbreviate everything because, well, space was limited at that point in time, and there was a maximum length of stuff. So not only is this code in Dutch, which already sucks, by the way, because that means you cannot sort of outsource it to whatever East European countries or Asia or whatever. That doesn't really work. It's also full of abbreviations, so nobody except the people who wrote this stuff could understand it. And the people who wrote this stuff, they were sort of like aging. They got older. They wanted to retire at some point, right? These are people in their 60s and slightly above. And that means within a few years, they were going to retire. So how do you deal with 18 million lines of COBOL if your developers are retiring? Well, you get them back from retirement, basically. That's what you do. And that's what a lot of companies are doing these days. So that's one of the problems you might have. I'll give you another one. This is my current client. It's an e-commerce company, and I love them to death because they're really great. And they have grown from having one deal on their website on a single page with an Excel spreadsheet behind it as their management tool into a company where we now have like 5,000-6,000 deals per day on the menu, right? So, and as a result, their landscape grew. So they had a bunch of web applications, a bunch of mobile applications. And at the point at the time that I got here, about 3.5 years ago, they could not deploy either their mobile app or their websites to production anymore because they had no idea what would break, right? Now, if you're an e-commerce company where you want to change everything every day, that's what the marketing team wants, and you cannot do that, and you haven't deployed your mobile app into production in 2.5 years, you're basically screwed, by the way. Then they also had a whole bunch of legacy systems. Then they started investing into microservices. All cool, right? And then they were like, oh, yeah, wait, we run on basically any cloud provider you can think of, and we'll just put everything everywhere, right? And then they had to work with a lot of external parties, so they interfaced with everything, and it's everywhere. As a result, over time, and basically because they had a limited amount of developers, they put everything everywhere. To give you an idea, the CMS system there is written in PHP. Okay, they had a PHP developer. So at some point they wanted to add accounts, people's clients, customer accounts. They were like, oh, you know what? We have a PHP developer. Let's just put them in the CMS. Which is not where you have to put your accounts, basically, by the way. So over time, data was sort of like replicated and duplicated and sent hands and forth with copying CSVs, emails, all sorts of interfaces, an ESB, et cetera, all in there, right? And in the end, nobody knew where they were. So they were totally stuck as well. They could not continue working anymore. They were basically doomed. And that's what I call technical death. That is basically the point. And you'll reach that eventually if you don't handle your technical debt, where the amount of time that goes into keeping everything running is a lot bigger than the time you can spend to sort of like innovate and continue to work. I had this at a company, a public transport company in the Netherlands. They could only release every 3 months. And you're like, okay, that's fine for us, but these days that's kind of unusual, right? And another client I worked for, they could only release once a year. Now that was a commercial product. They were a SaaS provider. They were basically doomed. They went bankrupt, by the way, so it does happen, okay? This really happens. Companies get stuck, and the question is, how do you get out of that? Now, it starts with identifying what the real problem is. And the good thing is, for us developers, is that the actual problem is hardly ever the actual technology. That's good, right? Because yes, we have technical debt and we suffer from it. It's in our hands all the time, but it's not us usually. It is usually the organization, or actually it's always the organization. It doesn't start with developers not doing their job. It starts with product owners, but it starts with managers, it starts with CDOs, it starts with CEOs who say, how hard can this be? You've heard that before, right? People saying to you, how hard can this be? And then I'm usually saying, okay, if it's not that hard, you build it yourself. I'm like, yeah, okay, we didn't mean to intrude on your territory, but how hard can it be? No, it's hard. Well, I don't believe you. We've done this before. No, we haven't. This is new, right? Those kind of talks that you have all the time. And you're always pushed and pressured to deliver as soon as possible. And as soon as possible usually means lower quality, it means technical debt. And as soon as you get to the level that the technical debt becomes too big, you're screwed. The second thing is this. It gets even worse because there's a thing called the Innovators Dilemma. Now, the Innovators Dilemma is basically shown in this graph. I'll explain it a little bit to you. It basically says, if you introduce a new product or service or whatever you do, at some point it will pick up, people start using it, it will get more popular, so you'll add more features. Because when you add more features, there's even more people adopting it. And the funny thing is, there's always this point where no matter how much stuff you still add to it, new features, new whatever you do, new stories, your growth curve sort of declines, right? And that is the point in time that you get into trouble. Because there will be other companies, wherever they are in the world these days, right? Because that doesn't matter anymore, who pick up on your business model, do it with newer technology, better solutions, because they're later in the game, and outpass you immediately. So, in the middle here, when you are in the dilemma zone, you need to reinvent yourself. You need to come up with something new to make the next 10 billion bucks, or 10 million bucks, or 10,000 bucks even, right? I once was at an event at Microsoft, and Microsoft said, it was in 2005 or whatever, and they're like, yeah, the whole model with Windows and Office, it's not going to fly. We need to invent something new. And they invented the cloud. Well, a lot of people did it at the same point in time. But this was in, 2004, 2005. And I was in Redmond, and I said, so what are you guys going to do? Well, we're going to build data centers. Well, everybody has a data center. Yeah, well, we're going to build our own, and we're going to run software on it. So what's your business model? We don't know. That is the point. They were at this innovator dilemma zone. And they got out of it, basically, so they built Azure. It had no name at that point in time. They had no business model. They just started doing this. And we asked the guy, so how much money are you guys going to spend? And they said, well, $3 billion. What? There you go, right? So they were huge at this. So anyway, the question is, what can you do? Well, let me introduce myself first. This is me. I'm an independent dad, as I used to call it, because I separated from the mom of my kids a long time ago. I got much happier out of it. I speak a bit, I write a bit, I travel a lot. I'm basically a CTO. That's what I do. But most of all what I do, I write code. I write code every day. I actually pushed to production already twice this morning. So I'm currently the CTO for this nice company called iBot, which is an e-commerce company, also active here in Belgium, but this is not a commercial talk. So we won the Website of the Year award last year. I had no idea why. I asked our CEO, did we buy this thing? He said, no, I didn't know either. I'm like, what? Cool. So I'm actually a programmer. You can see that in my name, right? So I am double object-oriented. Yeah, not much I could do, right? I could only become a developer at that point in time. It gets worse. This is where I live. In the Java street. That's not that serious. This is the view from my window, actually. And I do some stuff in open source as well. This is our TypeScript framework for microservices. Anyway, that's the intro, right? So the question is, how do you get unstuck? Once you get caught in the innovator's dilemma or in a technical debt situation, how do you get out of it? And what I'm going to tell you is basically the stuff that we've done about it. That doesn't mean it works for you, right? I always like to share this slide saying the just sharing principle. So it worked in our context. That doesn't mean it will work for you. It could. Or you could take away the parts that are good for you and throw away the rest of the talk. And if you take one thing out of it, I'm already happy, right? So here we go. The thing is, for most organizations, you cannot just do greenfield. You cannot just say, let's build this really big new system. That doesn't work, by the way, but let's build this really new system, greenfield, and we'll see how we get there. Because in most organizations, everything needs to stay running. So you need to be in a situation where, while you renovate and innovate, you also need to stay open. In an e-commerce company, that is literally the case. And that is the case I'm currently in, right? And the thing is, you have to set up a strategy to move out of here. But the problem with setting out strategies is that, and we come back to it's the organization, is that culture will eat your strategy for breakfast, right? Culture is way stronger than a strategy can ever be. So that means if you want to change stuff, you have to sort of inject it into people, into the culture, into the organization, to sort of make these changes. And they need to be really, really tiny. So the only thing to get out here is to take really, really tiny steps. Now, to show you that building these big new systems doesn't work, there's one more quote from John Goll. He says, well, basically, a complex system designed from scratch never works and cannot be patched up to make it work. You have to start over with a very simple working system. And the word simple in here, and working too, by the way, is the key word here. Because the simpler you can make stuff, the more stuff you cannot do, which is also, by the way, better for your energy consumption, the more stuff you don't do, the easier it is to get out there. And that's where you need to go. So, in order to illustrate it a little bit more, I'm going to tell you a little bit about the Cynefin frame. Have you seen this before? Nobody says yes, so I'll explain it a little bit. So this is a framework written by a guy called Dave Snowden. He says, well, basically, there is a bunch of zones that you can be in within the problem space you're in. If you're in the clear zone, that means there is a best practice for the problem you have. You better apply the best practice, and you're done, right? So the example I always give is like, in my kitchen, if there's dishes on the sink, I'll put them in the dishwasher, right? My kids know how to bring the stuff to the kitchen. They have no idea that there's a dishwasher underneath, right? So I'll put them in the dishwasher, done. Problem solved. Easy, right? If you are in the complicated zone, that means that there are good practices available, but you have to make a choice. If you have to make a choice, that means you have to do some analysis, figure it out which one to take. For instance, if you search for a new cloud provider, a new CDN, whatever you do, we're looking into a new load balancer and stuff. So we'll figure out what the alternatives are, try them out a bit, and then certainly at some point in time make a choice. That's how you roll. And then you can implement it. Still doable, still understandable. But if you get to the left side of this diagram, like here, that means you either are in a complex zone or chaotic zone, means there are no best or good practices. You might think, does it ever happen? It happens all the time. It's why we are in this industry, basically, because we do new stuff all the time, right? If we would do the repetitive stuff every day, that's the point that we get, well, outsourced or replaced by AI. It's the repetitive stuff. They can do that, right? Analyze the 18 million lines of code, even if it's in Dutch and full of abbreviations, you'll probably get something out of it. The problem is that this industry expands faster than the universe, which means there's no way to keep up with all this new stuff. And that's a problem. And because it's a problem, you get into the point where if you are solving a problem in your company, there is no best practice or good practice. You have to figure it out. So they might emerge from what you're doing, or they might not, which means you're in the chaotic zone. Now, given these zones, the question is, if you are suffering from technical debt, if you are suffering from the Innovators Dilemma, where do you think you are? Well, on the left side in the diagram. As a result, and I'm going through this list really shortly, is that if you're on the right side of the diagram, the first three numbers apply, right? But basically, most of us are in situations, well, where we say, okay, we need to solve this particular problem. We just don't know how. We sometimes not even understand the problem very well. And that is where you need to figure this out. So how do you figure it out? Well, that is where Dave Snowden's quote comes in. And Dave Snowden says, if you are in a chaotic context, this is the realm of the unknowables. The stuff you don't know that you don't know. And most of us will be here from time to time. And that, says Dave Snowden, is the best place to start innovating. And the question is, what does that mean, innovation? Well, it means basically that you need to experiment. And I'll show you a definition of an experiment probably on the next slide. The nice thing about being in experimentation mode is that, and this is a great quote, I actually love this. Jeff Bezos says, to invent, you have to experiment, right? If you know it's going to work, it's not an experiment. True, because then you're on the complicated zone, right? Most large organizations embrace the idea of invention or innovation, but are not willing to suffer the string of failed experiments necessary to get there. You need to allow yourself to fail. Think about it in your own situation. Are you allowed to fail? Are you allowed to say, I don't know, actually. We need to figure this out. And figuring it out basically means you cannot estimate it properly. So if managers, product owners, scrum masters, agile coaches, whoever, say to you, how long is this going to take? You should answer, we're in the complex zone. We don't know. Most organizations do not allow you to say, I don't know, even though it's the truth. They want you to make up some numbers. So you come up with t-shirt sizes or Fibonacci numbers. Whoa, it's a 13. What does that mean? I don't know. It's an arbitrary scale, right? If you're using the Fibonacci series on estimation in Scrum or whatever you do, it's pointless, it's totally made up. There is no scientific proof that this is actually correct, right? So it doesn't exist. So what is an experiment, actually? An experiment is basically a test done in order to learn something or to discover if something works or is true. So it could also be false. Experiments fail, right? We tried using, I'm not going to name them, but we tried using a different, let's call it internet cloud provider for our security recently. And we got into trouble because we broke our website basically, and then everybody got angry at us, and we're like, yeah, wait, we're trying this out. It could probably save some problems that we now have, but we're not 100% sure how to do this thing, so we're going to figure it out. Yes, that costs money, right? The site broke down for half an hour, and that was an issue, of course. But yeah, we're allowed to fail, so it's okay-ish, right? It's not very much okay. And the thing is, if you don't make any decisions, right? If you don't allow yourself to fail and you make no decisions, you'll get into trouble anyway, right? Gregor Hope says, complexity is nature's punishment for organizations that do not make decisions. And complexity is our enemy, basically, right? And you should know that as a developer. So basically, we all have to become this. I found this weird thing on the internet recently. Like, there's something called a cottywomble, typical English phrase, probably, right? And it says to travel purposely toward an as yet unknown destination. That is basically how it feels like if you're experimenting. And I hadn't heard of this word before. I just had to put it in. So here's the thing. You need to take small steps. Now, I think small steps should help you a lot easier than taking bigger steps. This is the difference between taking small steps and big steps. Big steps don't work, right? So you have to split up everything. In my situation, that basically meant that we started delivering features instead of projects. We stopped doing projects altogether. That means we only deliver individual features. The feature I was working on this morning, while sitting there, and there probably also, was basically that we open a sidebar to edit content on the website, live in production. People can edit the content, but they can also click next to the sidebar, and then their changes are gone. Makes sense to me, but it didn't make sense to the users. They said, if we have made changes, and we don't want to be able to click next to it, we want to click a button first to make sure that we get rid of the changes if we want to. Okay. So I was building that this morning. We're going to put it in production probably later this afternoon. I ran out of battery. So features, right? Second thing is shorter cycles. Do you use sprints? Who does sprints in their projects? And I suppose the rest who doesn't raise their hand don't dare to, because they're afraid I'm going to say something nasty about sprints. I will, by the way. So yes, we can go a lot shorter. How long are your cycles then? You should probably ask. Well, 17 minutes. I actually checked the pipeline just now, and it was 17 minutes. So that's why I say 17 minutes. We can go to production every 17. We go to production probably more often than once every 17 minutes. Take it into smaller teams, or different teams, actually. And also build smaller components, because smaller components are easy to get away, to get out. So let's do them, the first three. I'm not going to go into components, otherwise we'll be talking about software architecture for a long time. I'm not going to do that today. Here's the thing. What helps, and keep in mind that culture eats strategy for breakfast, is to figure out what the dotted horizon is of what you want to reach as an organization, or in the problem space you are, the context you are in. So I continuously ask the people, and this is the CEO and the CEO of the company I work for now, ask them, so what's your dotted horizon? Where do you want to be? Their original answer when I got there 3.5 years ago was, oh, we want to have higher revenue with bigger margins. I'm like, okay, let me build you some software to do that. I have no idea how to build software to do that, right? I cannot work on that, right? So you need a real mission statement. So we got one. And we figured this out, right? We said, we want to be Europe's leading deal site. Now, you might say, well, that's sort of like, it's ambitious, right? It is, but it's the dotted horizon. So meaning we're Europe's leading deal site means Europe. Europe is much bigger than the 6 countries that we're now active in, including Belgium, by the way. But and also we want to be a community of consumers. That means we build a strong community. That's what we're supposed to do. So that means I need to build software that does that. So I built a whole new command system, and I say I because I actually literally did it myself, which is multilingual. We didn't have that before because, well, we want to be Europe, so it needs to be multilingual. That means if you type in a command in Dutch on the Dutch website, it'll appear in French if you go in Wallonie, right? So that is a result of this statement, basically, that gives me the time to actually do this. Now, that's interesting, right? And the next question is, if you want to break through the culture of saying, no, we cannot do this and we don't want to change, that's how organizations usually respond to changes. Say, okay, if you want to get at the dotted horizon, you need to spend time on that. You need to be aware of the fact that you need to spend time on it and allocate that time. So as a result, we split up the work we do in tech in 3 different parts. We say, okay, 70% of our time, of the whole team basically, goes into reaching the dot, goes into building the features that we need to get to that point. 20% of our time is spent on sort of renovating the existing systems, and 10% is just solving bugs. To put it in more practice, I'll show you the way this works actually is that we have a group of people who are representatives of all the departments in the company that together decide on what are the items that will go into these 70%. And there's a bunch of criteria for it. First of all, we asked if anybody can propose anything, right? Our customers even, our suppliers, our own people, and every suggestion that comes up, we'll judge it, right? Or weigh it, basically. We'll say, does it help us reach our goals? Does it meet with the dot on the horizon? If not, we'll throw it away. So we haven't spent any time on it yet. Can we actually do this? Do we know how to do this? Or is this actually chaotic zone and we have no clue? In that case, you might doubt whether you should do this. Then the next question is it small enough? So can we actually do this within a certain limited amount of time? So we make a ballpark figure estimate, like 3 weeks, 2 months, those numbers, right? Not smaller than that, actually, because smaller than that doesn't really matter to us. And then the question is, do we really need this now? If this is something that is like, yeah, we might need this in the future, or maybe in 2 years, don't spend your time on that, because chances are big that you actually really don't need it. or never going to need it, basically. So get out of that. And the last question is, okay, maybe then someday maybe we'll put it in a separate column on a board saying, okay, we'll reinvestigate it in like 6 months or so. Usually the items that go into the someday maybe column get there because the people think it's urgent, and eventually we'll realize we're never going to do this stuff. But yeah, it keeps them happy. Don't tell them, by the way. So this is the board. It does. This is for the tech board. These are the bigger items. Yes, it's Jira. I'm not saying use Jira. I'm not suggesting that at all because I don't really understand this thing. But this is what it looks like. And then there's the second thing called the general board, which is also a Jira board. And then we have for the smaller items, just the bugs that we're solving every day. That's a Slack channel that everybody replies to basically on your own time, whenever you want to. Second thing, let's talk about cycles for a bit. So what is it with cycles? It's like everybody says, yeah, we have sprints, and they take 2 to 4 weeks. Most people use 2-week sprints these days. When the whole thing started, there were 4 to 6-week sprints, and it went shorter and shorter, right? And that's good, because I think the length of a cycle that we use is basically part of the changes that we have in technology. The better the technology is, the more we can do, maybe leverage AI in our life cycles as well, the shorter the cycles can become, right? We went from, when I started in this industry, I started making money with writing code in 1987 or something, and we had still waterfall. It existed. It actually has existed, right? And then we started getting into things like rational unified process, where we identified the need for iterations. And then we went shorter and shorter into DSDM and then Scrum, and we went into continuous delivery, and now we got to the point that we do continuous deployment, which basically means every piece of code that I write my unit test, I check it in, the pipeline will run, and as soon as the pipeline runs, it will land in production if everything's okay, literally. That pipeline runs for 70 minutes. I'll show you in a sec. So I think that it would be much better if we could actually have way shorter cycles than the ones that most people use. Because the shorter the cycles are, the more rapid you get feedback. And that means we get to a point in this industry where people still asking the questions, the Scrum Mastery types. Is anybody Scrum Master, by the way? If so, please put your hands in your ears then. Yes, but you're not doing Scrum right. There's all sorts of articles about, oh, we're not doing Scrum right. You're doing Scrum wrong. Here's how to do it right. Of course, this person probably knows. I have no idea who they are. Are you really doing Scrum? Follow these guidelines. This is what you need to do. It's okay to skip some Scrum runs, right? No, wrong. It's right, actually. You should skip all of them, basically. Or when they implement Scrum correctly, the frameworks delivers valuable benefits. I really, really seriously doubt that, by the way. The Scrum Masters or leader, coach, mentor, trainer first. It's their job to ensure the team works effectively with Scrum. Not with code, by the way, but with Scrum. Or this one is even better, right? This is what it says. The Scrum Guide contains the definition of Scrum. Changing the core design or ideas of Scrum, leaving out elements, or not following the rules of Scrum, covers up problems and limits the benefits of Scrum. Basically, they're saying you have to do it by the book, otherwise you're doing it wrong. And if you're doing it wrong, it will not produce value. That is not true, basically. I can be very brief about this. This is bullshit. So let me give you one example. So this is from a typical Scrum project, actually held here in Brussels in 2013, where this is a burn down chart, and they went wrong with the first. They either could not estimate their work, which you see in the top right, or they couldn't deliver what they thought they would be able to deliver, right? You've had this probably if you do sprints, like, shit, we still have some work left at the end of the sprint. And if you do that sprint after sprint after sprint after sprint, you get into trouble. Right? You have to work late in weekends, or they hire 300 people from India, which actually happened in this project, by the way. Of course, that didn't work because, well, if you add 300 people to a project that already fails, it's going to fail even harder, right? That's Brooks' law. So the project manager, yes, it had a project manager, he was fired, basically, and then with the project, it just failed miserably, cost millions and millions, basically. This is a stupid project. But they were doing Scrum by the book, right? So that's really weird. How can that fail? Well, it can fail for a multitude of reasons, right? We don't know exactly how to do this because, first of all, we're estimating stuff that we don't know how to do yet. That is really hard. You shouldn't do that, by the way. So you can either finish on time or early. So what do you do with the rest of the sprint? You're not allowed to add stuff to the sprint. Okay, now what? Well, let's go home. Or late acceptance, right? We've done all the work, but these stupid people from business, they don't want to test it. You've been there too, right? I have this stuff every week. Now they're on holiday, literally. I cannot put some of our bigger features now into production because the person who has to accept them, she's on vacation. 2 weeks. That is just plain stupid, right? Or you go too slow, or the scope creep, all sorts of reasons why it fails. The reason is, progress is not very linear, right? It doesn't go from it goes all the way down. The next sprint, you could go a lot slower than this sprint. Like our CEO says, I thought it would be done by now. And I'm like, oh, well, we ran into all sorts of complexities that we did not understand before. We didn't know about it. And yeah, but you're going so fast. You were almost done. Yeah, okay, now we run into this shit, right? So it's basically that. That is going to happen. There could be all sorts of progress in there. And the thing is, as my good friend Alan points out, is that Agile is not a process, right? Scrum is, sort of, but Agile is not. Agile is the ability to create your own. So how do you do that? And I got to the point that I was saying, let's put a comma in this phrase, right? We're not doing Scrum, right? Much better phrasing, I think. But you do want rapid feedback. So what do you do? So you go into shorter cycles. Deliver value continuously, on a daily basis, on an hourly basis even, right? And what Jez Humble says, the author of the Continuous Delivery book, he says, if it hurts, do it more frequently and bring the pain forward. He is talking about software, by the way, just to not confuse this stuff. So if you do a release every 3 months with a whole lot of changes, you need to test all that, integration test, system test, everything. It slows you down. So every time you do this, you get slower and slower, up to a point that you cannot deliver anymore. And that is the point where your dependencies have killed you. This is literally the chart from one of my clients in 2010 or something. Every rectangle here is the system. To implement something new, they had to go to all of these systems to test the whole thing. That is really scary shit. And the thing is, if you go into shorter cycles, this actually becomes true, right? If you miss the bus, but you know there's one after 5 minutes, you're okay, right? If you know the next one is in an hour, or the next day, you're into deeper shit, right? I was in Leuven last night for a concert, and I went back, and there was only one train that still ran until like 5 in the morning, and I have to be on this train, right? That is scary, because I did want to get back to you, right? But if there's a train the next 5 minutes, I don't mind missing one, right? That's the whole point. And this is a really strong thing. So you need to move into smaller items, smaller components that deliver stuff in smaller cycles. This means you deliver very tiny features all the time. By the way, in order to do this, you need to automate everything. Everything, that is. Everything you can automate, with or without AI, I couldn't care less. That is really highly vital. And it is exactly what Edward Deming said. He says, eliminate the need for massive inspection by building quality into the product in the first place. We're back at quality. Now, building quality into the product. If you think about the software we build, do you guys do pull requests? Why? Or code reviews? Or retrospectives? All that shit, it's always too late, right? It is not quality built into the product in the first place. This is just wrong. You should invest more into building fully automated pipelines. Let me show you. I'm going to show you. I'm not sure if I have enough time, but I do want to show this. Let's see if I'm, where is my browser? Oh, here's my browser. I actually opened it up, but I'm not wearing my glasses, so I'm not sure what I'm actually showing. Could be all sorts of whatever, right? Fuck. Oh, here's my glasses. This is not our pipeline. This is Sonar, but I have a pipeline open somewhere. Otherwise, I'll just open it somewhere. So let me open an arbitrary pipeline. The one for if there's an internet connection. Yep. Oh, offers pass. That's nice. So this is actually our pipeline for one of our micro apps, right? It goes into all sorts of stuff, all sorts of build steps, test steps. Sonar runs on it. We publish it to all sorts of environments. We deploy it, we web test it, we run it into acceptance, we do load testing, all sorts of shit, and then it runs into production. This pipeline ran for 14 minutes. So somebody checked in their code, ran the unit test, of course, on a local machine, and then put it into production in 14 minutes' time, right? This is the length of our cycle. Actually, the thing that I was working on this morning was a feature that was requested yesterday, and I'll probably put it into production later today, right? That is the speed that you can go at if you do this stuff. That also means that all your infrastructure should become code as well. There's no way you can manage all your infrastructure, especially if you go into microservices architectures, and just have everything configured by hand, right? There shouldn't be anybody here doing this. If something falls down, it should come up automatically. If it's not scalable enough, it should scale itself automatically, right? This is the shit that you need to automate all the time. That includes testing, right? Who of you has not written any, no, that's not a nice thing to say. So I suppose most of you have written unit tests this week if you're a developer, right? You should write unit tests for basically everything you do, because if you do that, it means you get rid of all the manual testing that people do. Manual testing takes time. Remember the person who went on a holiday and now we cannot deliver for 2 weeks? That's just waste, right? It means that the code is lying around. We make change it for all sorts of other features. Then in 2 weeks' time, it probably doesn't do anymore what we now promised to do. That is not right, right? You should shorten these cycles. In order to shorten these cycles, you need to write tests for everything. And it starts with writing unit tests for everything. And a unit test is basically something that runs in total isolation, right? You don't talk to a database. You don't talk to your environment. You don't talk to your file system. You don't talk to services in the cloud, whatever you do. You need to test stuff in isolation. Because if you do that, it will basically give you a sense of trust. So on our pipelines, there's tests running everywhere. On every stage, there's tests. And we add more tests to the pipeline anyway. The pipelines, by the way, are also scripted, which means if we add a stage to the pipeline, it will automatically pick up the next time it runs, and it will be on those pipelines. And then you can do stuff like a static code analysis. We run Sonar. Oh, I'll show you the Sonar, because I have it here, right? Where is Sonar? This is the this is the schedule. Oh, here's my Sonar. This is the Sonar on the same repo I just showed you. It has a code coverage of 85%, and on new code, because I just checked in some code this morning, it's 82%. So I need to up my game here a bit, because we have an agreement to do. Oh, you guys don't see that. That's weird. Sorry about that. I'll show you the slide anyway. So doing static code analysis in the pipeline, just add it to the pipelines and make sure it runs. Sonar, by the way, is free of use for most of us. So use this stuff in your pipelines, right? And start doing those checks. And do them so you build it into the product, right? So your pipeline is also your product. As a result, it gives you much more confidence about where to write your code and pushing the code to production. And we do that all the time. This person is still praying. He was a developer on one of my teams. He's, of course, praying because, well, he works in light mode. You don't do that. Yeah, let's be short about it. So last thing. I'm going to talk a little bit about teams. And I'm going to try to keep it brief, because I only have like 7 minutes to do it. So the famous Edgar Dijkstra said, the programmer has to be able to think in hierarchies that are much deeper than a single mind ever needed to face before. He's basically saying, and he said this, I think, in 1984, that our industry is more complex than any other industry out there. I'll give you one example. This is the tech stack of a company I worked for a while ago. I asked the developers, could you come up with all the tech that we use in this company? Now, this was a not too big company. It was a scale-up. They had 30 people in tech. And these 30 people in tech had to maintain this whole thing out there, right? As you can imagine, they got bought by another very large company and they got disbanded. The whole company disappeared. They couldn't do this. They couldn't even make any money out of it. They made no profit just because their tech debt and their running costs for the infrastructure was so high that they couldn't do this anymore. And it made me realize that as a developer, there is more in this industry that I don't know than there is I know. And I've been in this industry very long, so I think I might know a little bit about it. Still, there's so much more out there that I have no clue about. That's why we go to conferences, basically, right? To teach, to learn stuff that we haven't seen before. And as a result, the thing you can only say is, it's not you as an individual. It's the team that actually owns everything. It's the tech team that owns it. If you have multiple tech teams, they own all of them own it, right? So as a result, it means that everybody on the team should be enabled to do the stuff they need to do. And that is not easy, because most organizations still steer and still manage these people by individual KPIs. How much lines of code did you produce this year? Which is a very bad metric, by the way, because I have a negative code churn usually, so that means that I couldn't make any money. So there's the thing, right? So it's the team that owns this stuff. And as a team, and this is my team actually, you have to say this. If you are in the experimentation stage, which most of us are, that means you need to work very closely together. And this is us working closely together. We get into the office 1, maybe 2 days a week. Some of us 1 day a week, some of us 4 days a week. I like working in the office, but that's me. And you realize that you work together as if you are, let's say, an orchestra, or let's say a jazz big band, for instance, right? Where people play all sorts of instruments, all different instruments usually, and together they hold all the skills to do the stuff that they need to do. But they can also do it in smaller sets. So as a result, in tech, you might say, well, there's a collective, there's a group of people that holds all the skills together to be able to deliver what you need to deliver. And I had an interesting conversation with one of the guys on my team yesterday, and he said, well, it's not just that we have all the skills together, but we also have personalities that sort of fit together, right? I have a very different approach to things than he does. He's a complete finisher, I'm a starter, which means I start things, but I rarely finalize everything to the latest the point in the details. And he does that, actually. So he and I work perfectly nice together. And that goes for everything. So it's social skills, and it's also technical skills. And you can work together in these larger groups. So occasionally we have things like that. We stand together, we work on stuff, so another collective. And the funny thing is, it requires autonomy. Right? It requires you to allow yourself to do the stuff that you need to do at your speed, at your time, with your tech. But for a lot of people, that is outside of their comfort zone, because they have this urge to say, so what do you want me to do? When I picked up this team 3.5 years ago, they were like, yes, okay, but what do you want us to work on today? On the new TypeScript stuff, or do you want to work us on the Python ERP system? I'm like, okay, I don't know. I've been here 3 weeks. How would I decide that? I don't even want to decide, because you know much better than I do. So make up your own minds, right? But that is really tough. To teach people how to be autonomous is like this. I can tell them, if you want to draw an owl, okay, let's do circles, and the rest you need to figure out yourself. The only thing that I did figure out, by the way, and it was sort of inspired by the Hock principle, is that less rules helps. And he said basically this: simple, clear purpose and principles give rise to complex and intelligent behavior. That's what you want, basically, right? Complex rules and regulations give rise to simple and stupid behavior. Watch the Dutch traffic, right? We have traffic signs, like 4 of them on every corner of the street. Doesn't really work. People stop thinking. They just hit other cars because, well, I was going to green and you weren't. Even if you're going to green, you still need to watch the other people. So here's the thing, right? Simplify to amplify. I really, really like this sentence. And I'm going to run a little bit over time. So this is what it is. This is in Amsterdam, pretty close to where I live. And they, at some point, removed all the traffic signs from this square to see what would happen. And there were people saying, no, everybody will bump into each other and lots of accidents. What actually happened is that at this crossroads, people started to communicate. Right? You look what other people are doing. I usually, every morning when I cycle to work, I go from the middle to here. I just cross the crossroads diagonally, because I see all the other, I know where traffic is coming from. I do this every day. I look to the people where they are, and you can cross it diagonally, except when there's a BMW somewhere on the crossroads, because, well, they don't watch. Sorry if you have one. So this is it. So here's my team. And this is where we ended up. We ended up with having very, very little rules. They're all nicely going to the picture, right? And it's basically this. Antoine de Saint-Exupéry said it right now. He said, la perfection est atteinte non pas lorsqu'il n'y a plus rien à ajouter, mais lorsqu'il n'y a plus rien à retirer. For those people who don't speak French, perfection is only reached, let's do this short, when there's nothing left to remove, which is kind of cool, right? And that's where we went. We went into not doing Scrum or whatever, or Kanban either. We don't have sprints. We don't have a Scrum Master. We don't have a product owner. We don't do stories. We don't document, by the way. We don't estimate. We don't have retrospectives. What we really do is the whole day long, we talk to each other, and we solve one problem at a time, right? This is what we do. We talk to each other. And whether that's remote or here in the office, so the guy in the middle, he lives in a place called Heerlen, which is in the south of Limburg. We're in Amsterdam. He comes to the office about once every month. And the rest of us is like, well, we do all sorts of things. Like we have like a lean coffee session. This was the one from yesterday, where people can come up with topics and people can present whatever they want to, basically. And they do. So we looked at an Akamai demo yesterday. Somebody figured it out, did some experimentation, and that's it. And this is the strategy we use. We're solving one problem every day. Everybody on the team is doing it. We make the problems as small as possible, and then we solve them. Using small components, very, very short cycles, like the feature I was working on this morning. It's really tiny, but it delivers a lot of value to the people in our company, and that's really nice to do. So this is how we work, right? We realize that in this larger collective, there are no two different work items that you want to do at the same time that require exactly the same skill set. So you can do multiple of these small problems at the same time if your collective is big enough. That means that at any point in time, anybody in the team will actually be able to say, you know what, this thing is still on the board. On the tech board, it's bigger, so we need to look at it, or it's on the general board, so it's smaller, and just pick it up. They'll just pick it up. As the CTO, I'm not saying you need to pick up this and you need to pick up that. That's what they do. It's their work. It's their autonomy. And they'll form a team or do it on their own or do it with 2 of them or 3 of them. And we all have our preferences of the people that we like to work with and that we don't like to work with. And that's okay, right? And then we discuss the work and we do the work. I have a guy on my team who usually works at night. He can much better focus at night, so he works at night. So he misses the stand-up in the morning, and we all know that. And that's okay, right? Because we talk to him the rest of the day anyway. I like working on weekends. That means I check in my code on Sunday evening, and then stuff will be broken on Monday morning when people get into the office. It's a nice surprise to start your week, right? So we do that everywhere and all the time. We work in cafes, I work at conferences, people work from home, in the office, whatever makes them tick, right? It's their problem. So some examples. This is an ops guy and a developer, Java developer, by the way, very good Java developer, by the way. Here you see my current team. Typical of, on the right, Francisco is a front-ender. We're apparently looking at back-end code because he's like, what? And no, he can do that too, by the way, just a joke. Or like here, 2 Java developers and a tester. You can guess who the tester is, right? They have to stand. That's what you get when you're a tester. You should stand. And, or this one is also nice. This is an architect and a developer, also a Java developer, by the way. So the architect is for praying for it to work. He doesn't know, right? He's an architect. And it sort of works because it makes leadership very contextual. For everything that somebody picks up from the board, it's their choice. And they'll bring it home. And they do, actually, right? And I don't have to tell them what to do. We'll just talk about it, we'll do the work, and that's done. And then people ask me, like, does this really scale? To be honest, I don't care too much about where it scales. It works for us, right? This is the just sharing principle. And then the ING Bank, they said, well, we actually do this at scale. We use your ideas from a bunch of my talks, and we call it micro squats, whatever makes them tick, I don't care. And it works at scale. He says, free welcome to drop by at my tribe for a cup of coffee. He still hasn't done that, by the way. He hasn't given me any coffee yet so far. But anyway, it's a technique that works for us and probably works in a lot of other organizations as well. But it depends on the autonomy. And it also depends on your ability to be able to fail, to allow yourself to fail, right? Because that's what experimentation requires. So in short, we are mostly on the left side in this diagram. As a result, we don't know exactly how to plan our work. We don't know exactly how to estimate our work. That means all the techniques that are based on that, including lots of estimation and planning techniques, don't really work for most of us. Have to realize that. That means we mostly are, to get out of this technical debt and out of this Innovators Dilemma zones, is you have to do continuous renovation. You have to also keep in mind the people that still work with the legacy systems, because they will do that for a long time. You're not ready to get rid of it really soon, right? That means deliver features, not projects. Make the cycles as short as possible, and probably even shorter, right? 14 minutes, we're trying to up the pipeline so we can deliver more at the same time, right? Look at how teams are composed. Think about the autonomy and think about allowing the people to make the mistakes if they need to make mistakes. And that's all good, right? And write smaller components, but I haven't touched into that. So, less is more. It's greener too, right? So, but it is always more. If you have less code, if you have less security problems, you have less to maintain, you have less to test, it's less work. It saves you a lot of time. Also, solve one problem every day. That also goes for your personal life, by the way. Don't make the problems big, keep them small, investigate it. That's when I broke up with my ex, by the way. She's a waterfall type. And no, just kidding. Well, she is actually, but and you can never stop learning, right? Because this industry is expanding faster than the universe. And by the way, Never forget to have fun. Also, if everything else fails, you can always remove the node modules and do an npm install, right? So that's it for me for today. Sorry I ran 5 minutes over time. I tried to talk faster than I already do. If you have more questions, I'll be here because there's beer later. So feel free to link on LinkedIn or find me in other places. And thank you all for indulging me.